this chapter there is some derivation and along with that some problems what you need to discuss here. See, to solve that derivation and along with the problems, you need to define so many different definitions. You need to understand each and every word which is newly arrives here. So let's discuss about electric current and the circuit. What do you mean by electric current and what do you mean by electric circuit? Just have a look here. Electric circuit. I wrote the meaning of each and everything here. Just glance it over. A continuous and closed path of an electric current is called electric circuit. Do you remember in your home, your father, your neighbor used to say that is an electric circuit. What do you mean by that? Circuit. There is a wire which the electricity is passing, isn't it? That wire is closed, which is start with the one end and start with the one and another word end with the another end. Okay, this is how the closed path. So a continuous and the closed path of an electric current, we are going to call it as a electric circuit. And what do you mean by electric current? The amount of charge flowing through a particular area in unit time. See what happened here. In the one wire, if electricity flows, that one is the electric circuit. In that wire, how much time, how much electricity is passed? What we are going to calculate? The time and the charge. How much charge and how much time is passed in that particular wire? What we are going to calculate? That one is called the electric current. See, just have a look towards the sentence again. The amount of charge flow through a particular area, that is, see, the particular area in unit time, how much time actually it is flowing. Okay, this is how the electric current is. For this we have the formula, that is electric current is equals to I is equals to Q by T. This is the formula what you need to remember much. Why? Because there is some problem in your textbook which you need to solve under this. Fine. What do you mean by I? What do you mean by Q? What do you mean by T? Q is equals to charge. Q in the sense charge. T is equals to time, as I mentioned here. I is equals to current. So by this formula you came to know that the current, how we are going to mention the current here? The current we are going to mention by the I. T in the sense, as you know already, time. And charge, how we are going to mention? The charge always we are going to mention as a Q. Clear? The charge is a scalar quantity. What do you mean by scalar quantity? Which has the magnitude or which is going to depend on the magnitude. Okay, it is a direction. Oh, fine. So charge represented by Q or small q, as I mentioned already. And there will be in the physics, if we know about the any new factor, for that factor there will be the SI unit. What do you mean by this SI unit? See, the SI unit is the measuring units. Measuring units. It is a kilometer, there might be the liter, or there might be the kg. We used to use these words in our common days, right? So it is so common for us to use. But when come for this topic, that is a coulomb, we didn't use. That's why it's appeared so new for us. But this is a common thing for the electric charge. Fine. So for the charge, we have the SI unit, that is a coulomb. Okay. The SI unit of the electric charge is coulomb, which we are going to mention it as a C. And the next one, the charge contains nearly 6 into 10 to the power of 18 electrons. What do you mean by that? See, whenever we mention the charge, that is equals to 6 into 10 to the power of 18 electrons. If I mention charge in the sense, in that charge, there will be the 6 into 10 to the power of 18. See, in front of the 10, if I go on adding the 18 zeros, that is how the value will be. That much of the electrons is there in that charge. And the next one, electrons possess negative charge, that is 1.602 into 10 to the power of minus 19 coulomb. One electron, as I already mentioned, always when the electricity is passing in the wire, in the sense, we always going to represent it in the form of the negative, that is a electrons. Okay, this is what we are discussing about this electrons here also. So this electron possesses negative charge in one negative charge always. That is how much coulomb, if one electron possesses, in the sense how much coulomb is there, we are going to mention, that is a 1.602 into 10 to the power of minus 19 coulomb. Okay, fine. And the next one, the unit of electric current is ampere, that is A. Yes, For the current also, electric current also, we have the unit that is a ampere. We are going to mention it as in the form of the A. And the next, why we gave this ampere name? Because the scientist name called Andre Marie Ampere in the time period of 1775 to 1836 who discovered this one. So that's why we are going to call it as a ampere. And the next one, the small quantity of the current are expressed in milliampere or microampere. Listen it carefully. There might be a chances to measure the large quantity of the current and the small quantity of the current. So for that, if we want to mention or if we want to measure the small quantity of the current, we are going to mention in the form of the milliampere. That is 1 milliampere is equals to 10 to the power of minus 3 ampere, or microampere also we can call it as. The next one is instrument of the electric current. See, what do you mean by that? This shows that if one wire, some current is moving, I. Okay, this is the wire and current is moving. How much current is moving? How we are going to predict it? It is impossible for us to by seeing only, to identify by seeing, isn't it? So to identify how to measure the current in the wire, how much it is going to flow. So to measure this, we have the one instrument that is called ammeter. Okay, so ammeter is the one instrument which we are going to use to measure the electric current in a particular wire. And the next one, the current always flow from positive terminal to the negative terminal. This is the most important and the common mistake what students you guys will doing. See, let's have a look towards this diagram. How actually the diagram is, there is a different symbol. Okay, so what happens here, and also you can observe the arrow mark here. We can't keep the arrow mark how much we like. There is some particular process to put those arrow marks. See, always it has to pass from positive to negative. See here, some of the symbols I gave. This is the battery. Okay, see, this one is the battery. Fine. After that, what happens here? There is a line like this, and then the bulb, and the next one is the ammeter, and the next one is the key, and the next one is wire attached. This is the negative terminal, this is the positive terminal. Okay, so when went like this, from positive terminal to always it has to flow towards the negative terminal. Okay, this is how always you have to mention the arrow mark. Fine. So about this symbols we are going to discuss in the next topic. There is a detailed given for you guys in your textbook. Along with that, I am going to say about that. And listen it carefully. This diagram, there is a chances to come in your annual exam also. So be careful and learn clearly about this diagram.